Okay, programmers, welcome back. We're going to finish up this Simon game, and if my computer isn't going way too slow, which it is, you can see what we have so far. Which, when you enter the for code, it'll either blink red or blink green. And if you look over here, we have, oh my god, I'm running at 9 frames a second. That's probably because I'm trying to screen record. But you can see what the combination is. 1, 2, 2, 2. So if I say 1, 2, 2, 2, then it will blink green and it will show us a new combination. If I open up my viewer, actually here, let me actually run this in performance mode. We might get a little bit better frame rate. Yeah, okay. So I don't remember what the combination was, and we haven't built the Simon function yet. So I'm just going to hit 4 numbers, and it will likely have the wrong... Come on, get off the screen. Ugh, okay. Why is that still on the screen? There we go, it's off the screen now. And that's terrible. All right, here we go. 1, 2, 3, 4. And it says, hey, that's wrong. And you can see how delayed my web camera is. So then I don't know what the combo is, so I'm probably going to get it wrong every single time. So we just need to finish this up and build in the Simon function. Okay, I'm going to go ahead and turn off this camera for now. I don't think we need it. And it's just slowing everything down. Okay, so let's see. The first thing we need to do is we're going to create a we're going to have another override going in here. So we have this win-lose that flashes that green or that red light based on whether you win or you lost that round. And now we're going to have another one just like it, actually. Let's just copy it. And instead of calling it win-lose-1, just call it Simon. Okay, and patch it on into the override as well. Okay, so now we're going to have a system that turns on the lights based on the Simon playback. And how do we do that? Well, I went around a bunch of different ways to try to get this to work, and the best way that I could figure out is to use the timer chop and use the cycles on the timer chop. So create a timer chop. And with timer chop, you get a length, which is set to 10 seconds. Set this down to like 1 second for now. And if I hit start, it'll take 1 second and then it will say done, right? But instead of only playing through once, we want it to cycle through more than one time. So down here, this parameter here that says cycle, if you turn that on, and then by default cycle limit should be on. And we're changing this to 3 cycles because we're going to do 1 on the start and 1 on each cycle. So that's 1 plus 3 is 4, and that's how many numbers are in our combination is 4. Right? So if we have 3 cycles, you can see 1, 2, 3, 4. Or I should say 1 on start. 1, 2, 3, 4. How do we do things on cycles? Well, first of all, there's a channel coming out of this. If I send this to a null, whoops, I don't think that's a null. Let's try that again. Does it show us our channels? No, not really. It just says the same one. Actually, let's see here. Channel outputs. There we go. I could, if I wanted to, send this to cycles. And now you can see those cycles. It's on cycle 3 right now. 0, 1, 2, 3, right? And we could use like a chop exec off of that, but there's no need because you can run code directly off of this callbacks. This little pink button down here opens up a timer 1 callbacks, and in here you can run code on various things associated with this timer. Where are my callbacks code? There it is. Okay, so we can run code on initialize. We're not going to do that. We can run it on ready. We're not going to do that. We can run it on start, which we are going to do, and we can run it on cycle, and so forth. Yeah. Wow, I accidentally cut off something, but I think I can remember it anyway in my notes. All right, so we're going to run. Let's just delete the things that we're not going to run code on. So we're going to delete these two. We're not going to run code on those. We are going to run on start. We're not going to run on timer pulse. We're not going to run on timer active. We are not going to run on any of these. We're not going to run on cycle end either. We're just going to run on start, on cycle, and on done. Okay? And what we're going to run the same thing on start and cycle. First thing is we need to, no, actually, let's go ahead and put this code in. All right, so what we're going to do is we're going to set those values in Simon based on whether the number on cycle matches the combo number. So let me move combo down here so we can look at the same things. And luckily, combo's not actually attached to anything, so I can move it wherever I want. It's only attached through associations. So what we're going to be looking at is this cell, which is 1, 0, 1, 1, 1, 2, and 1, 3. And each round, we're going to set the Simon to whether that corresponding LED matches the number that's in the cell, in the column specified by what cycle we're on, right? So before we start, we're on cycle 0. If I go to this timer here and I click on back to initialize, you can see I'm on cycle 0, right? So that means when we start, we'll look at 0 or 1, 0, and that's a 1. And so we're going to ask, is the value in 1, 0 equal to 1? And then the answer there is yes, it is. And then that will turn on the LED. We also ask, is the value in 1, 0 equal to 2? Is the value in 1, 0 equal to 3? And those are going to be false. And so that will, if any other lights are on, it'll turn them off. So it'll only turn on the one that's supposed to be on for that cycle. So let's try this. All right, so we're going to say op Simon, because this is where we're looking at. We're looking at that Simon dat. No, sorry, we're looking at the, we're sending a value to the Simon constant chop, right? .par.value 0, that's the first value, that's going to be the red LED, equals. This is where it gets a little bit weird, but try to stick with me here. We're going to say open parenthesis, op, open parenthesis, single quote combo, single quote, close parenthesis, open bracket, 1, comma, because we're looking at the row 1, which is the second row. And then what number we're looking at is going to be this cycle, the value in cycles in this. But we have to cast that as an integer because by default everything is floats, and the dat table will get mad and say, I don't know what column you're talking about because you sent me a float value. So we have to cast it as an integer. So we have to say int, not inst, int, open parenthesis, Then we're going to talk about that cycle channel of the timer chop. So we're going to say op, open parenthesis, single quote, timer 1, single quote, close parenthesis, open bracket, the channel called cycles, close parenthesis, or sorry, single quote, close bracket, close parenthesis. So that will close that integer cast. Then we have to close bracket. Then we have to close the parenthesis that we started this one as. And then we have to say equals equals 1. Okay? So this is a little bit of a funky line, but that's it. And once you have one of these, we can copy and just change values, and it'll be pretty easy. So it's op, Simon, par, value 0 equals, open parentheses, op, open parentheses, single quote, combo, single quote, close parentheses, open bracket, 1, comma, int, open parentheses, op, open parentheses, single quote, timer 1, single quote, close parentheses, open bracket, single quote, cycles, single quote, close brackets, close parentheses, close bracket, close parentheses, equals equals 1. Okay? Let me zoom out. Now that we have that, we can copy this. I can't get it all on the same screen. Maybe I'm too zoomed in. There we go. No. There. I can copy this whole line. Copy, paste, paste. And then change this to value 1. This is value 2. This is op timer. I think this is all the same. And then you just say equals equals 2, equals equals 3. Okay. Now let's copy this into the cycles, the exact same code. So copy that on cycle, paste it in. We have to. There is a value that needs to be tabbed over right here. There we go. There we go. That can be the same. And then on done, we just want to reinitialize this timer because it tends to perform better when it's been initialized. So once it's done, it'll reinitialize ready for the next time it needs to be run. So op, single quote, timer 1, single quote, close parenthesis, dot par, dot, this is initialize, right? So dot par, dot initialize, there we go. Initialize dot, and then I think it's pulse, because the way you hit a button, I've told you this before, is you talk about the parameter and then you say pulse, open close parenthesis, and that will push that button. Okay, so that will do that. Now, because we don't want these lights to stay on, we want them to turn off after a certain amount of time. Because if we were to just leave it like this, then the light would be solid up until the next cycle, and it makes it kind of harder to see. It's better to have it. Turn off so that there's a little bit of a gap between when the first light lit and then when the second light will light. So it goes on, off, on, instead of being on, off, right? So to do that, we have to do a delay script. But we also, because we need this, because this is going to be changing how fast it goes over time, I can't just choose a certain number of frames to run this delay script on, because that number of frames may get to be too long if the timer runs too fast. So once the timer runs past a certain speed, we either have to have a really, really short number of frames on our delay script, which means it will just flash really, really small, and that's not really what we want either, because that makes it hard. or we need to create some kind of value that drives the length of this, like a constant that drives the length, not only the length of the cycle, but also the length of the delay for the delay script. Let's do that first, actually. So let's create a constant over here, constant, and we're going to call this, what is it called? Playback length. Playback length, the capital L. Okay, and over here, let's, instead of calling this chan1, let's call this seconds. Okay, and so this will represent how many seconds we want each cycle to be. And so over here on timer 1, I can, on my timer here on length, instead of just saying 1 second, I can specify this. So I can drag my playback length in here and say, make a chop reference. Okay, so playback length, seconds. Okay, now that we have that, this, we're going to create our delay scripts. So our delay scripts are going to be for turning off these LEDs. So let's call them delay off 1 equals, and then in quotes you put op, open parentheses, Simon, single quote, close parentheses, dot par, dot value, 0 equals 0. That'll set that, that'll turn off that Simon. And now we just need to copy this 3 times, or 2 more times. And then change this to delay off 2, delay off 3, and this is value 1 and value 2. So that will turn, when we run delay off 1, it'll turn off the red LED. When we run delay off 2, it'll turn off the green LED. When we run delay off 3, it'll turn off the blue LED. Okay, so we're going to do that after we've done this logic. We're going to run 3 delay scripts to turn off any LEDs that might be on. Op. Sorry, not op, just run. Run, open parenthesis, delay off. There's no quotes on this one. Just say delay off without quotes, comma. Then we have to tell it how many delay frames. Delay frames, and don't forget to capitalize your F. Delay frames equals, and here's where I was telling you, you can give it a set value, right? And that'll delay 3 frames, that'll delay 20 frames. But we don't know, because we're going to be changing how long the playback length is. We need to have this delay frame set by the playback length. So we're going to say equals, open parentheses, op, open parentheses, single quote, playback, capital length, spelled length wrong, there we go, nope, there we go, length, single quote, close parenthesis. We have to specify what channel we want to look at, which is channel 0, the only channel that's there. Or we could say channel, quote, seconds, but it's easier just to say 0. And then we want this to last, and this is in number of seconds. So if there was 1 in there, we want it to delay, we're going to do half the time. So if it was 1 second, we would multiply by 1 second for frames, and this runs at 30 frames or 60 frames a second. We would multiply this by 30 so that half the time it's on and half the time it's off. Right? If it's less than a second, that 30 is going to be less, it's going to be multiplied by 0.25 or something. So this will automatically work for us. And now we have to close this parenthesis. Is that right? So I have one open two open, one closed, two closed. Why do I have two parentheses on my other ones? Oh, because of the delay right here. So I have one open here, two open here, three open here, one closed, two closed, three closed. Okay, so that makes sense. All right. So now I can just paste that two more times. And instead of running delay off, oh, this needs to be delay off 1. This is delay off 2. This is delay off 3. Okay. That should work. Copy all of those. Just remember here, these have two parentheses at the end of this line. Okay. Copy all these three things and put them down here, because we're essentially doing the same thing on start and on cycle. And that should do that. All right. So if you did this right, we don't have an automatic system yet, but we can manually trigger this. If I go to timer here, and my combination right now is 1133, I should say initialize. And oh, change this. It says right now that's set to 0 seconds. That's too fast, obviously. Change that to 1 second. Okay. Now on my timer here, I can initialize this and hit start, and it should go 1133 on that Simon. 1133. The third channel. So it went 0 1 on the first channel, 0 1 on the first channel, 0 1 on the third channel, 0 1 on the third channel. Do it again. 1 1 3 3. Yep. There's a bug in that, and mine does this for some reason. Sometimes it misfires, and I haven't figured out how to fix it yet. Did it again. Oh, I think if you initialize it, it helps. 1 1 3. No. I think it's a frame rate issue. Yeah, it's failing a lot more than when I'm not screen recording. Hopefully on your system it won't be failing this much. And I'll see if I can't come up with a better system in the future. But this does work. They worked perfectly that time. All right. Cool. All right, so next is, I guess it just doesn't work that well at 14 frames a second. Next thing is we have to trigger this. We have to trigger this, and we're going to do that in back in our chop exec up here. Let's see. I believe it's the one that triggers the counter. So here on this chop exec, I have to find my program. There it is. Here's my notes. All right. So we have our flash or green light. That's if we win. So let's see here. If up, yeah. Okay, so if we win, we flash our green light, right? We make our new combination, and then we need to run our Simon. Actually, we need to make our Simon faster and then run our Simon. So let me make a note here. Make Simon faster. Okay, and we're going to do that just by taking that playback length and subtracting some value from it. So we're going to say op, open parentheses, single quote, playback length, single quote, close parentheses, channel 0. No, actually we have to say par value 0 when we're changing it. Par dot value 0 equals op, single quote, playback length. Now we're specifying the actual channel, 0. And then let's subtract like 0.02 from it. So every time you win, it'll get 0.02 seconds faster. You can make that bigger if you want your games to move faster. You can subtract 0.1 from it or something. Actually, let's make it 0.05. That'll go a little bit quicker. Okay, great. Now, and then we need to run Simon. And all we have to do there is say, oh, right. We need to run this on a delay because we're flashing that green light. So if we flash the green light, if we don't wait till that green light is done flashing, then Simon will be trying to run Simon at the same time as we're flashing that green light, and then one of them is not going to work right, or it'll confuse you. All right, so we have to wait till after the green light turns off. So we do delay frames 50 to turn that light off. So let's define our delay Simon here. Delay Simon equals op timer 1 dot par. I don't remember what it is. Let me check. It's going to be par dot start dot pulse. Pretty sure. All right, par dot start dot pulse, because that's how you push the button. Okay, and put that in quotes. So that's our delay Simon script. Delay Simon equals, in quotes, op timer 1 dot par dot start dot pulse, open close parentheses. And so then down here we're going to run Simon. We're going to say run delay Simon, comma, delay frames, we'll give them an extra 50 milliseconds, equals 100. Okay, because this stops at 50, we'll wait 50 milliseconds and then we'll run the Simon. Okay, else we're running delay lose, we're running delay frames, and we're going to run Simon again to remind you what the combination is supposed to be. So let's grab this, just copy that, and so then we just run Simon. Here we can put a note in here. Okay. I think the rest of it is fine. Do we want to reset the count? Yeah, oh, we got that. It's there. It's right there. Okay, great. I think that's it. All right, so now, let me go ahead and open up my window here. And I don't remember what the combination is, but I'm just going to hit 4 reds, and it goes, what am I on? Hold on. Why aren't I getting a win-lose combination? Alright, that means I have some kind of error here. Alright, let me reset my count. Reset. So whenever your chop exec doesn't run right, you're going to have to manually reset your count because it'll roll past 4 and then it will never trigger again. Alright, so what did I do wrong? It said op value, op playback length, error while scanning string literal. don't see what's wrong with... I see what's wrong. Single quote, close parentheses. That should fix that. Okay, let's try this again. So the combination is supposed to be 1133. 1, 1, and I say 2, 3. 2, 3. It says wrong, and it should tell me again 1, 1, 1, 3. Yeah, see that it's not running right because of the frame rate issues. 1, 1, 3. Wrong. 1, 1, 1, 3. Damn it. 1, 1, 3, 3. Now it's telling me the new combination, which is 2, 3, 3, 3. 2, 3, 3, 3. Yes. Now it's saying 3, 3, 2, 3. But it all said all threes because my thing doesn't run very good when I'm screen recording. Let's try running it in performance mode. Maybe it'll run better. Now that I can actually see what's going on. Other thing to note is see now that my playback length has gone down to 0.9. It was at 1. So let me close this. Let's go into performance mode and see if this is any better. It seems like it's better. Three, 3, 2, 2. 3, 3, 2, 2. No. 3, 3, 2, 3. Oh. 3, 3, 2, 3. Yes. 2, 3, 1, 3. 2, 3, 1, 3. Yes. All right, so now it's working. All right, there's just one more thing we want to do, and that's have a field up here for controlling the speed so that when it starts to get way too fast, you can just manually slow it down or change it if you want. All right, so to do that, I'm wondering if there isn't a better way to do this because I had to kind of create a convoluted system to make it work, but it does work. Okay, so here we go. We're going to create a field comp. A field comp is something that you can type data into, whether that be numbers or text. So field type up here, string, change that to float. Okay. Now go inside your field, and we need to have an input into this field. So we're going to send a because we want the changing value to change what's the text is in the field. So we need an in chop. This is in the project 1 field 1, right? In chop. Okay. Now on the in chop, we're going to attach that to a. Actually, just scroll out for a second, and I believe I just have the. Let's see. This playback length is patched into the in chop, like that. Okay. Now go back into your field. Okay, so now this is the amount of seconds that we have in our playback length. Okay, so now we're going to attach a chop exec to this. A chop exec dat. And the only code we're going to need is on value change. So let's just get rid of all this other code. Shouldn't have to change anything over here because on value change is the default. And so on value change, we want to update the string field here. So we're going to say on value change, come on, there we go. Op string channel 0, 0, right? That's 0 row, 0 column. Equals, sorry, close the bracket, equals, and then we just need to do this ins channel 0, op in channel 0. So that will set whatever we have in here. Every time it changes, it'll set that value. So now if I go out and I change this to 0.7, uh-oh, didn't work. Why? Open. It says none type is not subscriptable. Something called op-in. Oh, in one. Oops. In one. Okay. So now if I go out of here and I set this to a different value, you can see that that will populate. It has a lot more numbers than we need. So I think there's a way to change that in the parameters here. I can say floating decimal digits. Let's just make that 2. So now if I change this to 0.7, let's see, it just says 0.7. If I make it 0.75, it'll say 0.75. Okay? Now, so that sets the input for that field. You can also click on it and set your own input. But when you do that, so if I open a viewer here, here's my field down here. I can change this to 0.9, but it's not going to change this. So we need to create another system for doing that. So we do that by, what do we do? We go out of here and actually go back in here. We go out of the field and we take this to a, do I not have a picture of this? Yeah, send it to a null dat. Okay, so there's that value. Now we can reference that value and we can change that to a dat2. Alright, and I think there's a way to get rid of this. So change here where it says first column is names to first column is values. There we go. And now we need to send this to a chop exec. You're like, why can't I just patch this in here? Because it doesn't work that way because this is a constant. And that would also create an infinite loop that we don't want to have happen. So we need to go to a chop exec dat. And on this one, on value change, we can get rid of all this other code. We don't need it. Get rid of that. So on value change, op playback length dot par dot value 0 equals op what's it called, dat2 or something, dat21, dat21 single quote close parentheses channel 0. So it's really kind of a convoluted way of doing it with 2 different chop execs, but it works at least. So now if I go in this field, if I'm in my viewer here and I put 0.6 in here, then you can see that playback length has also updated to 6. Okay? So now we just need to label this thing and put it in the right place. So there's a couple different ways we could do that. We could probably just have a text object or something and put it above it. But I'm going to put it inside of here. And the way I'm going to do that is I'm going to change the size of this field here. Text, field, go to the common. Instead of this being like this, I'm going to say, instead of using input, I'm going to say custom resolution. And I want this to be, instead of parent width and height, I'm going to put a resolution. I'm going to put this as constants, and instead of 256 by 256, I want this to be 200 by 100. I think that's what I had. It's not in my notes, but I'm pretty sure it's 200 by 100. Okay. Why isn't it in my notes? It should have been in my notes. Whatever. Okay, it's font size on this. I'm going to change the font size to like 25 or so. That's probably good. Well, 31's too big. Here, I'm just going to type it in. 25. Okay, and I'm going to move this over like position 68. Yeah, so it's nice in the middle now. And I'm going to move it down to the bottom by putting like a -22 here. Right, like that. And now I'm going to put a label up here. So I'm going to put another text coming out of this. And instead of the word derivative, I'm going to put Simon length. And font size on this. Font. That's good. And then let's just move it up. Position. Here, I'll just use my value ladder. Whoops, not that one. This one. I'll go by tens. There we go. Alright, I like that. Now, if I go out, you're like, well, where's the Simon length? Right? That's because this is looking at, under look, it's looking at background top dot / text, which is this, and we want to look at dot / text 1. And there we go, Simon length. If I scroll out now, it's still tiny. Alright, so we just need to change its size. So here on there we go, width 200 by 100. That looks better. Okay, now we just need to position this on the screen somewhere convenient. So I'm going to move this, and I'm going to move it up on the Y to this top corner and over a little bit. There we go. Alright, so that should do it. Let's try it out. Let me close this. Let me go into performance mode. And I don't remember the combination, so I'm just going to say red, 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 red. That's wrong. It should be red, blue, blue, blue. Red, blue, blue, blue. Yep, and you can see that length has gone down. I don't remember. Red, blue, blue, red? Nope. Blue, 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 red. Blue, 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 red. Yes, and now I'm down to 0.5. Green, green, red, green. Yes. Green, blue, green, green. Yes. Blue, 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 blue. So it's getting faster and faster. Blue, blue, red, blue. Nope. Blue, red, red, blue. Yes. Green, green, red, blue. That's right. I said it wrong, but I did it right. Blue, 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 blue. Nope. Blue, blue, green, blue. Yes. See, it's getting really fast. Nope. Blue, blue, green, green. Nope. See, it's going too fast now, and so it's falling off the. Oh, I got it right. No. Maybe it's red, green, red, green, red, green, red, green. Yes. Oh my God! All right, it's just too fast. I can't see it anymore. So I'm gonna change this to point to. Actually, I'm gonna change it to 1. Nice and slow. All right, and red, green, red, red. No, that's not right. So now red, red, green, red. Okay. All right. So this is half of our asynchronous lesson was to finish this. So please do finish your Arduino Simon project. The other half of the asynchronous lessons will be for you to do 2 Matthew Regan generative video tutorials that I'm going to post links to on the class website. So you do this and you do those 2 tutorials, and then we'll look at more generative stuff on in class on Wednesday. So have a great weekend, and we'll see you on Wednesday.